Hi, hello everyone. Good morning to one and all. Today we will discuss a topic that is a Durbin version test. That is a DW test. Generally, we will call DW test. So previous classes we are discussed about that what is meant by autocorrelation and what are the causes and consequences of autocorrelation. How we can detect the autocorrelation. So we discussed about that basics of autocorrelations and how we can detect the autocorrelation also. Previously, we discussed that what is the graphic method, there's an autocorrelogram. Then the second one, that is how to detect the autocorrelation, there's a Durbin version test, DW test, which is very important to test the whether the problem is facing of autocorrelation or not. We will look at into that. There. So basically, we need to understand that what is meant by Durbin Watson, who was introduced the Durbin Watson test. So here, this test was developed by the Durbin and G.S. Watson. So these two people have developed the Durbin DW test. There is a Durbin and Watson. The two people was developed this test. So generally, it is popularly it is known as a Durbin Watson D Statistics. Durbin Watson D Statistics. Sometimes we will put in the Durbin Watson test values with D is equal to something. D is equal to 2.5 or 1.9 or 1.2 or 2 like that. So some people will represent DW or DW value. There is a Durbin Watson value. So it is popularly known as a Durbin Watson D statistic. So how we can calculate what it means that that is the main thing, that what it means of DW test. So simple, it is a ratio of sum of square differences. Nothing but it is a ratio of sum of square differences in successive residuals. Nothing but errors. So when you are finding that errors, that is y is equal to y cap, that is the actual value minus estimated value, then you will get the errors. So when you get error, so you need to sum up square differences, nothing but et minus 1, that is the present year minus its previous year error term value. Then when you square it and when you add it, that is a sum of square differences in successive residuals to the residual sum of squares. Residual sum of square, nothing but we need to add all the residuals of values, nothing but that is sum of residuals. That is called sum of e t square or ei square. The J. Durbin and Watson have suggested to test which is applicable to a small sample. So generally, the DW test will be applicable to the small sample. But sometimes we will use the DW test for the large sample also. But in the large sample, it may not be applicable, or which is not a good test for the large sample generally. So, however, the test is appropriate only for the first order regressive, autoregressive scheme. So, what is first order autoregressive? For example, when you are running a regression model, so when the model is a first order autoregressive, nothing but present year depends on only its previous year error term, not its more than its previous errors. Nothing but the present year is depends on only its previous. Like see, for example, here the equation ut the present year error is depends on only its previous year. If you take into account rho is equal rho ut minus 2, that is second order. That is a second order autoregressive. So when we are running such kind of model, we cannot run the DW test, which is not good or appropriate test for that when you are running a second order autoregressive model. So here, what I want to say that here, simple, the Durbin DW test for only small sample, and it is appropriate for the first order autoregressive models. Okay, so it may not applicable for that large sample, and also it may not applicable for the it is not appropriate for the second order or higher order. We can say that more than one order. We can say higher order. So how we can calculate the DW test or D statistic? So there is a formula simple as per the DW test is C. D is equal summation t to the n et minus 1 whole square divided by summation t to n et square. So what is et here? This sum is nothing but total summation sum total et. There is a present year error minus et minus 1. It's preceding its previous, or we can say the previous error term. So whatever we can get difference is the present year and its previous year. For example, if you take into account last day error and present error. For example, today error is 5. For example, if you take it to account, last day error is 4. 5 minus 4 and whole square like that. Then sum of ET square, nothing but sum of total residuals whole square. So that's how we can calculate these statistics also. We can come to know that. The next slide. So before calculating the D statistics, when you are running a regression analysis, so you need to keep in mind that whether the problem is facing autocorrelation problem or not. So for example, generally we can write when you're running a model in the time series as well as the cross section data. So here we can generally write autocorrelation. See, we need to assume or we need to frame a hypothesis that is a H0, that is a null hypothesis. That is rho is equal to 0. What it means, the coefficient of previous error term is 0. Nothing but present year is not depends on its previous year. Okay, that is errors are not correlated. Nothing but the present year error is not correlated with the its preceding or previous error term. So here H1, that is the alternative. So it is quite opposite to the null. See, simple, rho is not equal to 0. Nothing but, so we can get rho value is more than 0 or less than 0. That is rho is not equal to 0. So here rho is greater than 0 or less than 0. It means that, so the present year is correlated with its previous year. Maybe higher extent or lower extent, you can say that, or negative or positive. So that we need to keep in mind that when we are running a DW test, we need to frame some hypothesis like this H0, H0 is equal to P, rho is equal to 0, H1 is no, rho is not equal to 0. Okay. So this is the formula as I told you that. So generally, for example, if the D is equal to 2, what it means? If D is equal to 1, what it means? If D is equal to more than 2, what it means? Or D is equal to 0, what it means? Generally, see, if D is equal to more or less 2, 1 minus rho, then we can calculate it. So don't bother about this one. Simply, you can go with this. For example, see, when rho is equal to 0, when rho is equal to 0, when this is a rho cap, nothing but estimated coefficient of previous error term is equal to 0, the DW statistics, D is equal more or less equal to 2, approximately 2. Simple, you can remember. This is very important for that your PhD entrance or other entrance exams or assistant professor exams. They will ask such kind of questions in UGC net and site also. See here, when the sometimes they will ask such kind of question also. So if the DW test is more or less equal to the estimated coefficient of rho would be dash 0, 1 or plus 1 or minus 1 or more than 1, like that they will ask. So here, say simple, when the estimated rho is equal to 0, the D is equal to 2. Nothing but here, see, if the rho is equal to 0, it means nothing but the present year error is not depends on its previous year. The D is equal to 2. That is, it indicates that when the DW is the D statistics value 2, there is no autocorrelation in your problem. There is no autocorrelation in your problem. Say for example, when rho is equal to 1, when estimate rho is equal to 1, here it means what is mean by rho is equal to 1? It means that your present year depends on its previous year perfectly. So generally we can say that the D value will be 0. When rho is equal to 1, the D is equal to 0. It means that there is a autocorrelation problem in your model. And when rho is equal to minus 1, it means that present year depends on the previous, but negatively relation, nothing but negative association between the two variables. There is a present year and this previous year. So when the rho is equal to minus 1, the DW value or D statistics is 4. D statistics is 4. So simple, you can remember, if rho is equal to 0, D is equal to 2. If rho is equal to plus 1, D is equal to 0. If rho is equal to minus 1, D is equal to 4. Simple, on the base of these values, we can easily understand that D is equal, nothing but D value lies between 0 to 4. Simple, the Durbin Watson test values lies between 0 to 4. 0 to 4. Or between 0 and 4. Simple. So as I can see here, the Durbin Watson test statistics value between 0 and 4. If the D is equal to 0, what it means? Nothing. If D is equal to 0, the estimate coefficient of rho is equal to would be plus 1. If D is equal to 2, the row estimate row is equal to 0. If D is equal to 4, the row estimate row is equal to -1. Simple here. See, if you get the D value, as I told you, D value lies between 0 to 4. If D is equal 0 to 2, if you get the values D is equal 0 to 2, it means that there is a positive autocorrelation. Sorry, it is less than 2. Sorry, I'm saying sorry. So if D is equal to 0 to less than 2, nothing but it may be 1.7 or it may be 1.8 also. Sometimes we can consider, but there is a less autocorrelation. But there is a positive autocorrelation. If you get the D value is more than 2, 2 to 4, more than 2 to 4. See here, the D value is 2 to 4 indicates negative autocorrelation. Negative autocorrelation. For example, if D is equal to, exactly if D is equal to, there is no autocorrelation in your problem. There is no autocorrelation in your problem. For example, when you run a multiple regression or a simple regression, if D is equal to 2, there is no autocorrelation in your regression model. If D is equal to 4, there is a negative autocorrelation in your problem. If D is equal to less than 2, it may be 1.5 or 1 or 0.8 or 0.9 or 1.8 or 1.6 or 1.4, it means that there is a positive autocorrelation in your problem. Is it clear? Yeah. Then, how we can test the D statistic test? So there are 4 steps we need to follow. The first step, we need to estimate the regression analysis, nothing but coefficient of parameters. And we need to, after estimating the coefficient of parameters, we need to get residuals. That is called obtain the residual, nothing but errors. When you're estimating the model only, you will get the residuals. The residual is nothing but errors. How we can get errors? So y minus y cap. As I told you, error is equal to y minus y cap. That's the actual value minus estimated value. Then only we will come to know that what is the error. Then after calculating the residuals, we need to calculate the DW test statistic. Nothing but DW test. That is a D is equal sum of ET minus 1 whole square divided by sum of ET square. That we need to calculate it. Then after calculating the D statistics, then we need to obtain that there is a DL and DU. What is DL and DU? There is a D statistic lower value and D statistic upper value. There is a lower and upper points from the Durbin-Watson tables. So there is a the T distribution table, F distribution table, like that. So there is a DW, there is a test table also there, Durbin-Watson table also there. So within the Durbin-Watson distribution table, so there is a lower value and upper value. So we will look at into that. So after calculating that, after looking at lower value and upper value, then we will implement. There is an implementation of the decision rule, whether you want to reject your hypothesis or accept your hypothesis. Okay. So for example, if the D is relative to the DL and DU, for example, if like this, so this is the values, if you can take the decisions. Okay. So D is less than DL. Nothing but if you get D value is less than DL, so you may reject the null hypothesis of positive autocorrelation. So then if DL is less than or equal to D or less than or equal to DU, so there is no decision, nothing but if your D values lies between lower limit and upper limit, we cannot take any decision. Okay. If the D value is less than lower limit or higher than upper limit, we will take a decision, accept or reject. Okay. So then we will see that how we can test on the basis of some values only. We will look at then. First step. So before doing that Durbin-Watson D statistics, simple, we need to follow certain assumptions, such as there is a restrictive assumption. What are the restrictive assumptions when we have to apply this Durbin-Watson D statistics? The first one, there is an intercept in the model. When you are running a model, you can keep in mind that your model should be consist of intercept or constant value. That is a beta 0 or beta 1. Okay. Then second value, the second assumption, that is the X values are not stochastic. Whatever you are going to take the independent variables, that values are not stochastic. Then third assumption, the disturbances are AR1 process. What is error on process here? Disturbances are nothing but errors or auto-regressive, first order auto-regressive. That is error now one is nothing but first order auto-regressive, nothing but present year is depends on its previous year only. That's the ET is equal to rho ET minus 1, as I told you that. Okay. So then the model does not include a lag dependent variable as an explanatory variable. For example, when you run the model, see in a multiple regression, see yt is equal to beta 1, this is a contracept. Okay, beta 2 x2t plus beta 3 x23 beta 4 yt minus 1. What it means that the dependent variable is depends on its own lagged value. So as I told you in the previous classes that the present year expenditure is depends on its previous year expenditure. So when we have take this kind of model, so we can keep in mind that this model that model does not include a lag dependent variable as an explanatory variable. So when we are running this kind of model, so we cannot run DW test. If you run the d values, the result will be misleading. Okay, so then we will follow the step by step in order to test the DW test. The first one, estimation. So here I have taken that 4 independent variables. So here I estimated on the basis of this equation yt is equal to beta 0 plus beta 1 and beta 2 beta 3 beta 4. So I have taken 4 independent variables, 1 dependent variable. So the model would be like this. Okay, so I have put cap, that is the estimate values. Okay, so on the base of the values, the coefficient like this, variable 1, that is the x1, x2 variable value, x4 value. This is the coefficients values. So after getting the coefficient value, simple, we can need to obtain the residual. Simple here, how we can calculate the coefficient value? Or simple, there are some certain softwares are there, Excel, SPSS, eViews, Stata, and other softwares are there. But simple, you will get in the Excel also. Okay. So here, these are values of actual values. I have taken this actual values. So when you are estimating the values, there is a estimated value, there is a predicted y values. This is the predicted y values. So after there is nothing but errors. How I can get residuals errors? Y minus y cap. There is a actual value. Y is nothing but actual value. Y cap nothing but y hat nothing but predicted or estimated y. So here see 26.84126078 minus 26.9336456. So when you take these two values, you will get minus 0.09238. These are residuals. That is errors. Residuals are errors. So in the for the all observations, see I have taken 31 observation in my sample. So on the base of these values, these are residuals. So after obtain the residuals, the first step is we need to estimate the model and obtain the residuals. Then next what we have to do, there is a estimation of the or DW test, D statistics. The second one is the D statistics. So simple here, see. So I have reduced the decimals here. There is a ET. So previously 0.09 here, 0.09, 0.09, 0.14. See here, I have reduced the decimals here. Okay. So in order to follow this D statistic, DET is nothing but present year error minus previous year error. Okay, it is ET minus 1. Okay. Then what we have to do, ET minus 1. So here I consider how I have taken the ET minus 1. So this is the present year 0.09. We don't have that previous year error. That's why I put at 0. So this year in the second observation 0.09. Its previous year is this one, minus 0.09. So see this is 0.09. Its previous year this one. 0.15. This previous year this one. So 0.3 its previous is 0.15. Like that we can take it. Sorry, for example, if you take this last one, 31 observation, 0.20. What is it? Previous ET minus 1, this one, 0.14. So at the last, we cannot take into consideration because we are not considering about next one because we don't have the 32nd observation value. So here, See ET minus ET minus 1. See ET minus ET minus 1. So this value minus this one. How much? Minus 0.09 minus 0? Minus 0.09. Then 0.09 minus 0.09? 0.19. 0.09, 0.09. 0. 0.15, 0.04, 0.9. So here 0.05. You can take decimals because if you take this one, so it should be 6, but when you consider the decimals, it may be value will be changes. So 0.03, 0.15, see minus 0.12. Like this, we can calculate ET minus ET minus 1. Then what we have to do the next? ET minus ET minus whole square. Whatever we got value, we can whole square. That is a ET minus ET minus 1 whole square. Nothing but 0.09, 0.09 into 0.09. Minus plus 0.09 into 0.09. You will get 0.01. So like this 0.0 into 0. So if you 0.05 into 0.05. So here like this you will get these values. So after calculating this 0. ET minus 1 whole square, if you sum these values, that is sum of ET minus ET minus 1 whole square. If that is 0.18. Then sum of T to N ET minus whole square, that is called ET square. What is ET is here? This one. If you multiply this whole square, nothing but ET whole square, nothing but 0.09 to 0.09, 0.01. So 0.09 to 0.01, 0.0 same value. So 0.15 into 0.15, you will get 0.025 like this. So here 0.09 to 0.09, you will get 0.009 like this. So if you add all these values, sum of ET square, sum of ET square is a 0.29. So simple, we can substitute these values in the formula of D statistic. Sum of ET minus ET1 minus 1 whole square is equal to 18, 0.18 divided by sum of ET square. So sum of ET square 0.28, 0.28. So when you cancel this 2, there is 0.18, 0.18 and 0.28. So you will get D is equal to 0.64, 0.64. So what it means, as I told you, what if the D is equal to 0 to less than 2, there is a positive autocorrelation. It means that there is a positive autocorrelation, positive autocorrelation. If D is equal to 2, what it means, there is no autocorrelation, there is no autocorrelation. If D is equal to 4, what it means, there is a negative autocorrelation, there is a negative autocorrelation. So after calculating the D statistics only, then we will come to know, we will obtain the DL and DU. That is a Durbin-Watson test lower limit and upper limit. How we can check it? Okay. So here D value is 0.64. See here how we can check the DL and DU limits. So we can keep in mind that number of samples. How many samples we have taken here? Observation 31. So here we can see this is a basic economics book in Gujarati. We have in the particular 862 page, we have the DW statistic value at 0.05 level of significance. So another table will be there 0.01 level of significance. So I have considered only 0.05. So that's why I have taken this table. So this is a number of sample observation 31. So and what is K4 and K1, K2, K3, K4 up to K10 and 11? What is K here? Parameters. How many parameters you have taken? Nothing but how many independent variables you have taken in your model. So as I told you that I have taken 4 independent variables. That is called K is equal to 4. Okay, here we can exclude the dependent variable. Keep in mind in your model. So that's why K is equal to 4. So within the K is equal to 4, we have DL and DU. There is a DL degrees of Durbin-Watson lower limit and upper limit, DL and DU. So simple, you can take into consider this one. Lower and upper limit 1.160, there is a lower limit, and upper limit is 1.735. So what is the D value is? It is not lies between these two values because we cannot take any decision when the D value lies between these two values. There is a 1.160 to 1.735. So simple, I can show how it can be reject or accept. The fourth step, say implement. So as I told you that number of sample N is equal to 31, K is equal to 4, D upper limit is 1.160, DU nothing but 1.735. So simple on the base of, for example, see. So as I told you that DL is 1.160 upper limit. Okay. So what is the D value is how much? 0.064. So simple when you observe this DL value and this D value. So here D value is less than DL value. It means that we can reject our null hypothesis. That is null hypothesis. It means that there is a positive autocorrelation in your model. Okay. So simple, we can accept our alternative hypothesis. Okay. If D is equal something, for example, if D is okay, well, in case of C, if D is equal 1.2, how we can take decision? So if 1.2, we cannot take any decision. This is in conclusion. Nothing but we cannot take any decision because we can come to know that our hypothesis is reject or accept. Okay. But there is a positive autocorrelation like this. For example, if D is equal to more than 3 or 2, simple, we can fail to reject our hypothesis. Okay. In that case only, we will take decision. So you see here, as I told you that if a computer D value is less than DL, nothing but our D value is 0.64. That is a calculator. The table value is 1.160. Yeah. See here, if the D value is less than DL, so as per our values, D is less than DL value. So there is evidence of positive and first order serial correlation. So as I told you, there is a positive correlation. So there is evidence. So if it is greater than 1.735, there is no evidence. Nothing but if DV is equal to, if you get 1.735, so there is no evidence of autocorrelation, positive autocorrelation. So that's why in when you are running a multiple regression, so if D value is very close to the 2, simple, it may be less than 2, it may be greater than 2, but there is a no autocorrelation problem. Generally, we can consider if D is equal to more or less equal to 2. It may be less than 2, greater than 2. But if you want to see accurate results, you can keep in mind that, so simple, you will take into consider DL value and DU. That is a lower limit and upper limit of the D statistic value. So as I told you that if the D value lies between this value and this value, if D is equal to something, for example, if D is equal to 1.2 or 1.3, so there is a inconclusive evidence. Nothing but we cannot say that the problem is there is a autocorrelation problem, either positive or negative. So regarding the presence of absence of positive and negative autocorrelation. So this is how we can see. So this is test how we can test the Durbin version test, how we can reject or accept. For example, in a computer examination, they will ask such kind of questions. Or for set and net and other entrances of MPhil and PhD in central universities and other universities, and also assistant professorship in other universities and some public service commissions. So they will ask such kind of questions. See, find out the DW value when estimated rho is equal to 0 minus 0.275. They will ask question like this. If they will give the rho value, we can find out the DW value. How we can find out? So in order to get D value is equal to 1 minus estimator, that is a rho cap. Think about estimated rho value. So already they have given the rho value, but we need to consider D value. So D is equal, as it is, you can take 2, 1 minus estimate rho is equal to how much? Minus 0.275. So here, if you multiply this minus and minus plus, okay, then D is equal to D, 2, 2. So then 1, if you multiply this plus and minus plus, so 1 into 0.27, 1.275. Then D is equal, if you multiply with 2, 2 into 1.275, you can get 2.55. D is equal to 2.55. So here DW value is 2.55. So then whether check whether our answer is right or wrong. So sometimes also they will give the DW value, then we need to find out the rho value. That is the rho value. For example, as I told you that if the D value is very close to 2, Okay, whether the particular problem is affecting by the auto-collection or not, then we will check. And also, they will give the d value, and we need to find out the row. So see, in order to find out the row value, when d value is dw value is 2.55, this one. So in order to get the row value, row is equal to 1 minus d by 2. 1 minus d by 2. That's the d value. That's the d Durbin version test value. So here row is equal to 1 as it is, minus d value is 2.55 divided by 2. So then row is equal 1 as it is, have taken minus 1. So when you cancel it, 2.55 by 2, you will get 1.275. So row is equal 1 minus 1.275. When you can take into consideration 1 minus 1.275. So automatically you will get minus 0. Sorry. Here typical mistake. Okay. See here, when you take into consideration 1 minus 1.275. So if you take into consideration, you will get minus 0.275. See, yeah, this value and this value will be the same. You have to find out the row and DW. So sometimes they will ask Durbin version value, sometimes they will ask the row value. There is a coefficient of previous error return. Okay. So the last one. So there are some drawbacks when you calculate the Durbin version test. So as I told you previously also, sometimes there is some drawbacks of any test. Here also the Durbin version test have some drawbacks, such as first one is it may be give inconclusive results. Sometimes it may be give inconclusive results. For example, if d value is lies between dl and du values, we cannot come to know that whether the particular problem is getting positive autocorrelation or negative autocorrelation. Then second one, it is not applicable when the lag dependent variable is used. So as I told you in the restrictive assumptions, that when you are taking to consider the dependent variable, its lagged value. So we cannot consider that model, and there are some drawbacks. And it cannot take into account higher order of autocorrelation. What is higher order? Nothing but as I told you that in higher order, so present error is depends on its previous error terms. Nothing but present error, the ET is equal to row ET minus 1 plus row ET minus 2 plus row ET minus 3. That is a present year depends on last year, and present year last year is so it's previous last year, like this. So that is a it cannot take account higher order of auto regressive. That is a AR2, auto regressive 2, auto regressive 3. So there are some drawbacks of this Durbin version test. So I hope so most of the students have understood how we can calculate the Durbin version test. What is meant by Durbin version test? So what is the value of Durbin version? So how much values lies between these two, and how we can calculate the Durbin version? How we can reject the hypothesis of Durbin autocorrelation or not autocorrelation? And okay, so thank you everyone for patiently listening. So if you like this video, so please share, subscribe to get more updates with regard to related to the econometrics as well as statistics. So thank you, one and all.